What if we wanted to add these three vectors? To add vectors, we have to make them into components first. A equals 7 at negative 45. So to get the x component, we had to do magnitude cosine theta. To get the y component, magnitude sine theta. At 45 degrees, the angle is split, so you get the same number. So B, we do magnitude cosine theta to get the x component, magnitude theta to get the y component. C, magnitude cosine theta to get the x component, magnitude sine theta to get the y component. Now, the resultant means we just add up all of our x components. X, 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 y, 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 gives us that. To get the length, you know what to do next. Pythagorean theorem. X component squared plus y component squared equals r equals 8.11. The direction is found using the inverse tangent, which will give us the opposite direction because the x component is negative. Arctan y over x gives us 30, so the correct direction is actually negative 150 degrees. Vectors can be subtracted just like normal vectors can. If a and b are vectors, there are two ways to calculate a minus b. Instead of doing vector subtraction, do vector addition with the opposite. That is, do a plus negative b rather than a minus b. Use the tip-to-tip method for subtracting vectors. Personally, I prefer doing addition of the opposite rather than doing the tip-to-tip. You're going to subtract vectors pretty rarely, but if you do the addition of the negative, then that means you only have to remember how to add vectors. You only have to do the tail to tip. You don't have to worry about tip to tip or tail to tip, because that can be a little confusing, at least to me with my limited intellectual capabilities. Let's say you're given a and b, and you need to calculate the difference a minus b. So, one way is to add a plus negative b. The vector negative b is exactly like the vector b, but points in the opposite direction. This is called anti-parallel. So you can see if I were to draw a parallel vector over here, it would be running along this line. If it's anti-parallel, it's flipped, as you can see right here. Anti-parallel. Adding a to the opposite of b is shown below using the tail to tip method. The resultant is the white vector. Tail to tail. The same resultant a minus b can be found simply by drawing vector starting at the tip of b and going to the tip of a. This is called the tip to tip method, and the white resultant is shown below in the left diagram. Note it is the same resultant from adding the opposite of b, so it doesn't matter either way. Saying a minus b is kind of like saying final minus initial, so we start our resultant b and end on the resultant a, the final. Just like with addition, we'll need to be able to deal with vectors and components to do vector subtraction. So if we are given two vectors, we have the x component and the y component. X component of the resultant is the difference of the x components and the b components. If you're struggling with x component and y component, remember x horizontal, y, just as if it were a graph. That's all that means. So when you start seeing those subscripts on your equation sheets for x's, sub x's, that just means you need to keep your x's and y's separately. There is no combining them unless you do it the right way, and what we're doing right now is doing it the right way, combining the components together. The x component of the resultant is the difference of the x components of a and b. So the x component of the resultant is 5 minus negative 3, which gives us a positive 8. The y component of the resultant is the difference of the y components a and b. So the y component is 3 minus positive 7 equals negative 4. if we multiply a vector by a scalar, let's say we have A. What would 2A be? It would be double the length, same direction, right? If we have vector B below, what would half of B be? Oh, negative 1/2 of B. So we would cut it in half, and then we would flip it. Negative half of B would be a vector that is in the opposite direction as B and half as long. If we multiply a vector A by a scalar K, then the resultant is a new vector that is just K, absolute value of K, times as long as A, and points in the same direction if K is greater than 0, and if K is less than 0, it'll point in the opposite direction. If a vector is multiplied by a scalar, then its components are also multiplied by the same scalar. Example. If we have A equals 3, 4, what is 5A? 15, 20, right? Because 3 times 5 is 15, 5 times 4 is 20, which are the components of A multiplied by the scalar 5. The end. Time for some test your understanding. Hopefully you're getting this.